afternoon, everyone. I am Keshav and I would be moderating the webinar today. Today's topic is Intro to Internet of Things. This topic will give insights on the network of smart embedded devices that communicate with each other and with cloud-based applications. Today we have with us Mr. Girish Deshpande, Director Engineering at Mindtree Limited. Girish has 19 years of experience writing software and managing projects, programs, and industrial systems. Girish has managed projects that encompasses technologies from open source, web applications, mobile applications, embedded products to testing. Gentlemen, you can ask your questions by typing in the chat pane available in webinar software, and Girish would take your questions during the webinar. So without further ado, I invite Girish. Over to you, Girish, now.
Hi Keshav, can you hear me now?
Voice is coming fine.
Okay, very good. Thanks Keshav for the introduction. Good afternoon everybody. My name is Girish Deshpande, and as Keshav said, I am a technical director in Mindtree. And today I'm going to talk on Internet of Things, or it also known as machine-to-machine communication. In Mindtree, we do some of these technologies and some of these products we develop for our customers, and we have some expertise in this area. So I will now start my presentation. So agenda for this, I hope you can see the slide. The agenda for this webinar is this. So we will see what is IoT, or Internet of Things, what is enabling the growth of IoT in general. We will also see many applications and examples of IoT. These examples will help us understand the IoT architecture and its benefits. We will also see some of the challenges that the industry will have to overcome to realize the goal of what we call ambient or pervasive intelligence, which is the ultimate goal of IoT. So let us see what is IoT. If you look at the evolution of Internet or web, the web 1.0 was mostly static, and it was basically one way to deliver static content, mostly HTML pages, and they were viewed by the humans, basically the users, and not much of interaction other than navigating through the websites. Then we had a Web 2.0 a few years ago, and which was a lot more interactive. And we had a two-way communication between a user and the application, web application. And the data basically flows between the users and the website freely. And most of the time, the transaction is still initiated by the humans. Examples are basically social networking sites, technologies like web services, those kind of examples, Facebook, Google+, etc. And now we are talking about Web 3.0, where it is not only for humans, but also the intelligent or smart objects and smart machines will interact with each other. They will also interact with humans. Humans will interact with machines. So the interesting feature of this IoT will be a lot of transactions will be initiated by the machines, unlike today's where humans initiate most of the transactions. And they will also influence, they will also control each other. The examples of basically Internet of Things and M2M, what we are going to see today. So these are some of the definitions which I found on Internet about for the Internet of Things IoT. I have listed down 3 of them. The first definition is a world where physical objects are seamlessly integrated into the information network, and the physical objects can become active participants in business processes. Services are available to interact with the smart objects over the Internet, query and change their status, and any information associated with them, taking into account security and physical issues. Second definition is the network formed by things or objects having identities, virtual personalities, operating in smart spaces using intelligent interfaces to connect and communicate with the users and social and environmental context. And third definition is interesting, which says the point in time when more devices or objects are connected to Internet than humans. Now, you can see I have highlighted a few keywords here that help us understand the nature of IoT. We are talking about hard, real, physical objects connecting to information network. Now, they are active participants in the business transactions. So the word active is very important here. They make available their services in the form of web services on Internet. Other objects can use these services to communicate with these objects. So web services may become the predominant form by which you can access the functionality of these objects on the Internet. The way today the web applications are accessed or expose their services to other applications. We are also talking of objects with identities and personalities. What does it mean? It means each object can be individually addressed on the network, and it has specific function or purpose to perform in the scheme of things. So it has specific definite context, it has a functionality, it has a role to play. The smart object is known for something, and it is closely tied to its social and environmental context. So that also is important. So it has a specific role to play in that particular network and that particular system. We'll go to the next slide now. So here you can see, we will see some of the characteristics of the IoT. First of all, it is a network of networks. So it is not a single homogeneous kind of network. There are multiple networks in this. Lot of local networks, many local networks, and which will be connected to the Internet. Now, each local network of these smart objects, basically they will form a local system, and the collection of such systems will form higher order systems. So it is also a system of systems, you can say. And how they will be connected, how the local network will connect with the Internet, and how the objects which are inside the local network will be accessed over Internet. That's where the gateways will come in the picture. And these gateways will help local networks to connect with the Internet. So the gateways will basically expose web services which either provide access to the objects and their data, or provide some sort of aggregate reports to the requester. So that will also we'll see. So for example, these gateways may perform more a smarter role, where they have an understanding of their local network, their local system, and users or other objects will interact with the gateways in a transparent manner, and the gateways will fulfill the needs of other systems or other objects or humans. So gateways will be important in this hybrid kind of networks. Okay, and it will also have basically, so you will have different kinds of networks. You will have networks where objects are connected directly to Internet, and they have their IP address which can be accessed. And then you will also have networks where it will be local network, like say a ZigBee kind of network at home, which will get connected with internet using gateways. Now the M2M stands for the machine-to-machine communication. The machines interact with other machines the way humans interact with the system today. People use M2M and IoT words interchangeably, the technology words. The typical smart object or machine will have local sensing, embedded computing, and actuator functionality. And of course, local storage also. Okay. And the smart objects, they can sense their local environment, and then they will process this information using their embedded computing and storage capability. And then the processed data will be either shared with other objects or humans or the systems. Or the objects can also influence local environment using their actuators. So the object can act and can do some action in the real world, or the objects just send information, like for example alerts to either a human operator or other systems like say SCADA systems which are monitoring the networks to take some action. Okay, so that will so the typical intelligent or smart objects will have these three things basically: sensing, embedded computing, and actuator. Okay. So we'll go to next slide now. So let us see what are the enablers of these IoT. So definitely the cheaper processing power. So the devices are getting cheaper and cheaper, as we know, because of Moore's law, and they're also getting smaller, and they're becoming more and more energy efficient. And also another big enabler or important enabler is basically the advances in wireless communication technologies and standardized protocols. So today interoperability is very important. Without interoperability, you cannot have such networks where objects can talk to each other. And today we have, so a lot of effort has been put to come up with the standards and the protocols. And these are some of the examples of the technologies and the standards which are listed, like RFID, ZigBee, Bluetooth, IPv6, 6LoWPAN, etc. Also, the emergence of cloud technologies will have an impact, an interesting impact. So now these devices are anyway connected to the network. So definitely they can access the resources which are made available on the cloud. So now you have the possibility of massive storage and processing capability available to the individual devices. And this can result in pretty interesting applications. And today, if you know, the mobile computing is the main driver for adoption of cloud technologies. So the organizations today are adopting cloud technologies first for mobile kind of applications. So this will have impact on M2M or IoT world also. And now the trend towards more smarter, self-aware, and self-caring, self-healing kind of networks. So we will expect network to take care of itself. So sort of adopting kind of networks where they can configure themselves. The devices can discover. They can, if there is a problem with one node, then they can find alternate routes, basically. For example, mesh technologies in communications, and we'll make sure that the network is robust, the network is working and reliable. That is one of the trend. Also, there is a trend towards more and more analytics in the products, where the devices are getting smarter. So now the devices have sensing, so they can access, they can sense their environment, and they will generate the data. So what do you do with this data, basically? So either the device itself or the higher order systems, they can use this data, they can analyze this data and take real life decisions. So, for example, one example of this is predictive analytics, where the product or system can monitor the sensor inputs, and then it can predict imminent or coming problems and take action. So those kind of analytics or that kind of smartness is being built in the products today, and we see more of that. Of course, the IPv6, where we'll have a lot more addresses available, because we are talking about more than 60 billion kind of objects which can get connected to the internet. So we will need a lot more addresses to identify these objects. So now let us see the IoT applications, some of the applications. So the smart grid, so this is the first example I'm taking, which is a smart grid. So what is the advantage? So this is one example where you can use such network of smart objects to conserve the resources or to optimize consumption of the resources. And the smart grid is a classic example of am I audible, Keshu?
You're audible.
I'm audible, right? Because I saw your message. That's right. Okay.
No. Please continue. Thank you.
So okay, yeah. So the smart grid is a classic example of Internet of Things, and so if you look at it, it is a huge network encompassing power plants, transmission network, distribution network, substations, and all the way down to the end consumer premises. So it is a huge network, okay. And when implemented, it is expected to save energy, a lot of energy, and use more clean energy resources. So they say you can use clean resources, in ad hoc manner only if you have that kind of smart network, okay. And it can, for example, send requests to reduce the load. That is one of the example. So it can send the instructions down to the consumers to reduce the load, say for example during the peak hours, and then also offer incentives to do so. So it can continuously transmit, for example, variable billing rates, and encourage load shifting to non-peak hours. Okay, so which is called the demand response kind of schemes. They're already being implemented in countries like US. Now it is possible only if the utilities can go all the way down to consumers. And typically the way it happens is they send these instructions to either home energy gateway, or they send the instructions to the smart meter. And the smart meter or home energy gateway is connected to the appliances at home. Like for example, your air conditioner, washing machine, your refrigerator, your motor, lighting, etc. So if you have programmed your smart meter or home energy gateway to accept such instructions from the utilities, then that gateway or smart meter can instruct your appliances to either switch off or reduce the consumption of the load. So advantage, so what is the advantage of that? So in the particular, say a big metro, if you implement these kind of schemes, then it can reduce the load. Today what happens, at least in Western countries, when there is a load, peak load, they have to fire temporary power plants based on, say, a gas, which are more expensive. Or if there is a demand, consistent demand, then they have to add more power plants. Okay, so all that can be avoided, and you can basically shift the load to non-peak hours by this kind of scheme, and you can incentivize the users for that. Now the smart grid is a network of networks. So in home, or in a building, commercial building, you will have local home area networks. Okay, say for example Zigbee home automation or Zigbee smart energy profile kind of network. Okay, which is connected in turn to the larger network. Now, either through smart meter or a dedicated home energy gateway. So the smart meter also can work as a gateway or dedicated home energy gateway you can use. So it becomes like a hybrid. Okay, because the devices which are the appliances which are at home, okay, you cannot access them over internet. You have to go through the gateway. Okay. Now there are substations, okay, which get connected in that locality. The substations serve the locality. Now each substation may also have a local real-time network of their own, and they may use more reliable kind of network, which is more reliable than what you find on the internet. And again, that network will get connected through gateway to the larger internet. The smart grid is a two-way energy and information transfer network, and this is possible only if we have real-time sensing and smart devices which can take real-time decisions. The smart grid is full of very smart devices, smart sensing, because everywhere across the board, for example, power plants with transmission, okay, all the way to substation and at home, everywhere you will have to take a real-time decisions. All the devices need to be smart, and they need to talk to each other, and they need to sense impending problems and take corrective actions. And there has to be a lot of predictive capability in the smart grid. Only then you can have a smart grid which is a self-healing and reliable kind of grid. Okay. One example of this, for example, sensing system, for example, can detect the transformer issues and can take actions. So systems are available, so a lot of sensors are attached to this transformer, and things like oil temperature and water content in the oil, etc., are measured continuously, and the predictive analytics algorithm inside the system can predict impending problem and can take action. Now, another aspect of smart grid is, now the smart grid is a huge network and very smart network, so supposed to be. Now it is possible only if you have a well-developed communication standards. So devices can talk to each other. So there are a lot of standards which have been defined, okay, for each aspect. For example, for the different standards for your buildings or homes, and there are different standards inside the substation. And there are different standards, say for example, for communication between smart meter and the utility. Okay, so a lot of standards so that the devices can talk to each other. So this is an example, a good example of IoT. The next example is smart building. Basically, the advantage of such kind of network inside the building is basically human comfort and also safety. It can ensure. Now, a typical modern building, you have many appliances, and these appliances are getting smarter and smarter, and they have sophisticated electronics embedded into them. They are also network enabled, so that they can talk to each other, and you have a supervisory control system, monitoring system, which can keep an eye on all these things, the entire system, and make sure everything is working fine. Some of the examples which you can see there, like air conditioning, fire safety, access control, video surveillance, lighting, elevators. So many examples are there. Okay. Gas leak detectors, those kind of things. And in a smart building, these systems will interface with each other, forming basically coordinated networks. I just give one use case, okay, so we'll understand the advantage of such network. If, for example, the access control system detects very less occupancy or no occupancy in the office or in the, say, a room, okay, one big room, for example, then it can ask the HVAC system or a lighting system to switch off in that room. Okay, so that will help save the energy and the money also. Okay. Now, if the entire building is sparsely occupied, then it can even switch off one or two elevators to save the energy. If in case of fire, for example, the fire system can ask the access control system to unlock all the doors. Okay, and all these things can happen, without human intervention. If the system is programmed well and it has its built-in intelligence, then the whole system will have its own smartness or intelligence or its own brain, and it can take some actions in these kind of situations. So that is the advantage of this. And you will start seeing, it's already happening, and you will start seeing more and more such kind of smart systems inside the building. An advantage of this is basically it is human comfort, human safety, I said, but also energy conservation. So when all these things work together, you can save also energy and cost. Okay, so this is automotive applications. So things like, say, intelligent transport system. The intelligent transport systems will have, for example, on highway, for example, where they are talking about the system where the vehicles will interact with each other. The vehicle can talk to each other, communicate with each other. The sensors along the road will read the traffic situation, we can detect the problems like accidents, etc. The toll collection and those things will be automated. It's already happening. So it is automated. And so the advantage of this kind of system where the things are networked is you can have a much larger traffic density on the same roads. And one example of the smartness where the smart devices is collision avoidance and automatic braking systems, which are available in high-end cars like Mercedes-Benz, where you see the vehicles can detect the impending problems like accidents, which is going to happen, and they can apply the brakes. Okay, so now you can see that these systems are slowly going to mimic a human behavior, and they will start taking certain action in real life without human intervention. And another example of this is, of course, autopilot, what you see in commercial aircrafts. And the same kind of systems are slowly coming to the end users and in the cars. This is another example where you can use it for the tracking behavior, for example. Maybe the retail applications, or I just given an example of car insurance. So you have programs today, like pay-as-you-drive schemes, where car insurance companies, for example, they will charge you based on the driver behavior and driving habits. So the car has a onboard unit which is connected to the internal systems of the car, like, say, engine control systems or braking systems. They can detect, for example, your braking habits. Okay, so how do you apply the brakes? They can detect your speed. The GPS systems, they can find out your location, they can find out your speed, they can find out your driving behavior, and based on that, they can charge you. So today, for example, people are profiled based on their age, demographics, education, those kind of things, and sometimes even color of the car. Instead of that, it will be more of individual tracking, basically, individual behavior that will determine how much car insurance you pay. Another example is retail, for example, where video surveillance and sensors are used to see where the consumers, the customers linger, where they spend more time when they move around. And based on this information, you can redesign your retail layout. Basically, you can optimize your layout for your benefits. Another advantage of this IoT or so-called M2M will be, the enhanced situational awareness. So when you have all these sensors, so you see typical Internet of Things, many of these devices will be sensors. Okay, then there will be devices which will read these sensor inputs and act upon that. Okay, they will act upon that. But majority of the devices, the smart objects, so-called smart objects, will be sensors, and they'll be deployed in the field. Okay, and most of these sensors will be wirelessly enabled, so you can deploy them in large quantity and wherever they are. Okay, now when you have such a sensor network deployed in the field, it opens up a lot of opportunities basically, and you can learn a lot about your situation or about that area. So one example is, for example, precision farming and cattle tracking, where the farmers are using, in at least in developed nations, farmers are using a lot of sensors, okay, to understand say, soil conditions, and there is no water or no fertilizer, lack of nutrients, those kind of things. Okay, and there are many such applications where enhanced situational awareness can be used to detect the problems, okay, which are going to occur ahead of time, and maybe take a proactive steps to mitigate those risks. Okay, so one example is this precision farming. Okay, it not only avoids problems but also it can improve your yield. Okay, the other example is which I listed here is this aircrafts, for example. So aircraft manufacturers, they are installing the sensors to understand what is the conditions of it. So for example, airframe or internal systems, and these are like wireless kind of sensors which will sense the local environments around them, and so that you can find out if there is a problem. Third example is this video surveillance. So today, if you see, the video surveillance is not like what it was before, where it just used to record what was happening in front of the camera. But you have very sophisticated built-in analytics, video analytics in these cameras, for example. Now, just to give an example, in the Bangalore police, they have installed a lot of cameras in many intersections. And what the cameras do, they keep an eye on the road. And especially when you stop at the signal, if you cross the white line, then the camera will detect the violation. Okay, so they will find out that you have violated the line, which is like a tripwire. So you have gone beyond the line, that white line. Then they will zoom in to your number plate, and they will read the number plate. Okay. Now, and then they will analyze this number plate. Now, the number plate, that in India there is no set standard for number plates, and there are different kinds of vehicles. Like auto rickshaws have number plates somewhere, cars have somewhere, trucks have somewhere. But still, those cameras have the capability to understand what is the vehicle, where is the number plate, zoom into that number plate, read the number, and then interpret the number and find out the details of the owner, okay, and generate the ticket, okay. And then basically, when you get the letter, you can go to the website and see yourself, okay. You will see the picture of your car and the violation and number plate, etc. All these things basically happen, without much human intervention, okay. Maybe except later, but identification of the violation, detection of violation, the number plate reading, and all these things happen without human intervention. So that kind of intelligence is same thing, for example, another example is say airport. Okay, somebody comes and keeps the objects, keeps his bag and walks away. Today, it will be detected immediately. Okay, cameras are watching everything, and they can find out the left objects immediately. Similarly, if there is a violation of one way, you are not supposed to walk through the door, but if somebody is walking through the door, they can detect. Cameras can read the face, and they can identify the face. Okay, they can identify whose face this is. Okay, so face recognition is there. So There is another example of what you can do with enhanced situational awareness if you have such capabilities. We talked about sensor network. We also talked about a lot of this data analytics that you can use to take decisions. These are some of the examples. Okay, so there, for example, assisted living, okay, or helping old people to live alone, but still you want to monitor them, their conditions and their health continuously. So you install, basically use the sensors, different kinds of sensors, and on the patient, and you can monitor the health of the patient, and you can do that remotely. Okay. Also, there is a concept of smart dust where in very large quantity you spread sensors in a geographic area. There I given one example, which is like water pollution, but it has applications also in, say for example, battlefield defense application, where you basically spread or spray these very small, tiny sensors, and these sensors will monitor the environment where they are in, they are dropped. They will form ad hoc network. They will discover themselves. They will become part of the network. They will have that kind of flexibility, and when they will start communicating, okay, to start routing, so they will have a mesh kind of capability. So those kind of wireless sensors you will see more and more. And one of these features of such wireless sensors is power. So many of these sensors will take power from, say, solar or their environment, wherever they are. Like scavenging, energy scavenging or energy harvesting, as they say. If there is a vibration available, then they will use the vibration to generate energy. If there is a solar available, then they will use solar thermal energy. They will use thermal to generate the power that they need. These are industrial applications. We know that the robots are already part of assembly lines, where they perform many of their activities without human intervention in the factories, for example. Many more applications, are being conceived, and so these are basically what we are talking about: autonomous systems which perform tasks that humans do today. Okay? And so slowly, machines will take over more and more what humans do. For example, is packaging. Okay, so where packaging, for example, if there is a problem when you print on the package, then you can have video-based system where they can detect even small problems in the print, okay, of the package, and then they can reject those packages. Or in the assembly line, okay, in this example, what you see, sensors and actuators can be used to change the position. So many a times the objects need to come in the proper order. Otherwise, it can cause an assembly jam, okay, and it can cause delays and cost money. So you can use automatic systems using sensors and actuators which avoid such things, which you save basically a cost or the efforts. And more and more this feedback control, you might have heard this, where you feed back to the controller which is doing some action in real time, and you will have systems where they will start taking such actions. Where, depending on the situation, they will find out what corrections they need to make, what offsets they need to apply, and keep the system in a balanced state. How many of you have seen last week or 2 weeks ago, there was a demonstration in the TED by Dr. Vijay Kumar, who is a professor in one of the US college university, and he demonstrated flying robot. Okay, and it's amazing demonstration. basically. Okay, where he has seen, he has shown what you can do if you have such smart objects, and these are very small robots. Okay, and you can fit them on the palm of your hand. Okay, so what he has shown in that demo basically that swarms of robots coordinate with each other. Okay, and to perform very complex tasks. And you have to see that video to really believe it. Okay, so what kind of things is this thing? So the last example what they have shown in the demo is they actually play music. They coordinate with each other and they play music. Also, they can fly in the formation, and even if there is the obstacle, they can detect the obstacle, take real-time decisions rapidly. Okay, and then work together. And basically, they try to mimic human decision making. Okay, almost feels like a science fiction when you watch the video. So that is a trend basically. We want to go towards systems which are very, very autonomous. They can work together, okay, and they can do the complex task together. So if you see these robots, individually they are very small, but he has demonstrated that when two such robots work together, they can lift very heavy objects. Okay, and they have demonstrated that these robots actually build a structure like a building. Okay, and these robots also have a capability. Okay, they can they have their own sensing. Okay, so if you let them go inside the building, they can scan the environment and they can form. Okay, how this building looks. Okay, like sort of blueprint basically, and they can use this information to navigate later. So all these capabilities you can have in the objects. So what are we aiming for really? Okay, so from the data, we are going towards wisdom. So data is basically measured values, sensed values. Information you can say is a relationship of measured values with real-world parameters. So what part? Then knowledge from the information we put knowledge where we detect and understand patterns basically. So we know the answers like when it happens, how it happens, where it happens. And finally, wisdom, where we know the principles and then we can use these principles. So for example, we know what the do's and don'ts. Okay? We know why something happens, okay? What happens, those things. So that is the aim of our study. Now, so this is all fine, okay? It is, all these network of smart objects doing such fantastic things. Okay? But what are really the challenges and issues? There are a lot of challenges ahead for such kind of Internet of Things, okay, whether in a small scale or in a large scale. Security, safety, and privacy. So these are the big challenges in front of us. Now, when you connect all these billions of devices to Internet, then you basically provide billions of entry points for malicious attacks. There are so many ways you can hack into the system. And once you hack into the system, you can do a lot of things depending on what is available with you. Okay, to you. Imagine if the hackers, just an example, they take charge of smart grid, okay, and so through the smart meter, for example, they access the utility system, and from there they access all the smart meters in that area which are connected to their system. What can happen? They can switch off the power. Okay, so today smart meters have a capability of remote disconnect and remote connect. But typically it is used, to disconnect power remotely. For example, if you don't pay the bill, then they want to disconnect remotely. So want to avoid a visit. Or for example, if you move out of home and you give them a call, they will disconnect the power. So this capability is already there. Now, if hackers have the access to this system, then they can cause a lot of damage. Okay, and there's also one capability in the smart meters, which is remote firmware upgrade. Okay, so Now you can also upgrade the firmware, and you can install the malware, for example, in millions of meters which are connected in that particular city to the utility system. So what may happen? I mean, if you want to, for example, take corrective action, and depending on situation, the only option left will be go door to door and change the firmware, because the firmware which is installed, the malware which is installed in the smart meter may not allow any more firmware upgrade. So the only way to change the firmware will be to visit and change the firmware. So which is massive headache for the utilities, and this can happen. And the researchers have demonstrated that such kind of things are feasible, is possible. Okay. Other implications, I take the same example of smart grid or smart meters, and another implication is privacy. Okay. Now, if I have access to your smart meter data, then I can infer a lot of things about you. Okay. So I can find out, for example, when do you switch on your TV? When do you switch off the TV? So there are a specific signature. Okay, when you switch on the TV and switch off. I can find out when do you switch on your washing machine. I can find out when do you leave home, okay, or when I know everybody, all occupants leave the home, and when do they come back. I can have the inference, for example, do you get up at night, okay, go to bathroom and switch on light. So many things I can find out if I have access to your meter data. And this meter data is sent to the utility every 15 minutes. So with that kind of granularity, you can do a lot of things. Okay. So this has implications basically. Okay. So if you hack into the systems of smart objects, it can cause a lot of damage basically, and also safety. Okay. Many of you might have read about Stuxnet kind of attack, where Siemens SCADA system was compromised. Okay, and so the specific product from specific company was compromised. They came to know about the vulnerability or weakness, and now this is the industrial SCADA, which is used to control power plants or, for example, wastewater or water, for example, treatment plant, those kind of things. Now, when you compromise such SCADA system, so the function of SCADA system is to keep an eye on all the sensors and all the systems, okay, safety systems and all these things, and take corrective actions. So if there is a problem reported, then SCADA systems will initiate the action. Now, when you compromise such system, it has implications. Okay? It has implications on safety. Say the safety of the personnel working in the plant, or even the safety of the end consumers, for example. Okay. So when you have the world where, in the world where billions of such systems are connected, okay, whether at your home or your offices or your factories, power plants, nuclear plants, your highways, intelligent highway systems and all these things, then it can pose a real challenge in terms of security and safety. You need to understand that compared to corporate IT, ensuring security and safety of this kind of internet of smart objects will be very difficult and very different. Okay, in the corporate IT world, you can immediately release the patch. It is homogeneous network, okay, and you can take action immediately. While here, it is a network of networks, and you have the products from the different vendors, okay, across the geography, and there are systems. We talked about wireless sensors, okay. We talked about the sensors which are deployed, okay, in large numbers in the field. Now, how are you going to apply the patch? If there is a problem with such systems, or take a transmission network, okay, electricity network, it is spread across geography. Okay, so how do you apply the patches and how do you ensure? Okay. So these are the big challenges, and the experts or the researchers are grappling with these issues. Another problem will be availability. Okay, another challenge, because the denial of service kind of attacks can disable part of the system or whole system. We just talked about the smart meter. They can basically cause a blackout in that locality. We talked about the confidentiality of data. If I access your data, then I know a lot about you. Okay, and also the data integrity. I mean, if I have access to the data, and I know how the data works, your data communication protocol works, then I can send the wrong data also. Okay, and I can cause a lot of issue. So these are the main concerns today we have when you have so many such objects connected to the internet. Go to the next slide. So these are a few more challenges what we have. So these are mostly like technical challenges, I can say. Now, although the standards have been developed and new ones are being developed as we speak, interoperability is still an issue. Okay, we talked about smart grid. Okay, smart grid alone, okay, it is just one application. It is just one industry. There are more than 70 potential standards that have been identified by the standards that we call the NIST list. Okay, we are just talking about just one application, one use case. Inside the building, for example, building automation. If you take, we talked about smart building. There are different standards. Okay, we have standards like BACnet, lawn works. There are so many standards. Okay, and all these standards are competing with each other, basically, and each proclaims that that is the standard, okay, to use. So we still don't know which standards will emerge victorious and which are the standards. So today, for example, if you want to adopt the standard, you don't know whether that standard will prevail. There is no guarantee. So you are basically taking a chance when you adopt a standard. Now, next is the cost. Now, although the cost is dropping, okay, it still needs to drop even more for, say, applications like wireless sensors. Okay, if you want to deploy wireless sensors, in huge numbers, then the cost has to be negligible. It should be very less. Okay. You also need a better decision support system. Okay, more intuitive, more visual, so that the human operators, okay, who are taking decisions, who are making sense of this huge amount of data that is generated by all these devices and it is coming towards central applications. Okay, to make sense of this data, we will need a more sophisticated kind of applications. And data mining and reporting is still a challenge. Now, we are talking about the network. We are talking about the internet. Okay, obviously, and we are talking about devices which will communicate with each other, will influence each other, will coordinate with each other, and will take collective decisions to accomplish a goal. Now, all this is possible only if we have the network which is solid network, reliable. Okay, so that is the foundation, basically, for this IoT. So the reliability of the network, performance of the network, these are the key issues, especially when we are entrusting all these devices to coordinate their activities with each other. These are a few more challenges. Now, although energy management is improved a lot from what it was, you still need objects that will operate in the field for a long duration without grid power. For example, wireless sensors again. The wireless sensors, one of the benefits of wireless sensors, just because they are wireless, one of the benefits is you can locate them, you can place them where otherwise you cannot place. Maybe in a hostile or very hot environment or very cold environment, for example, okay, where you may not be able to use wires or cables. Or in a factory, for example, in industrial application, there may be a lot of vibrations, there may be a lot of noise, the electromagnetic kind of interference. There may be heat. Okay, so it may not be easy to lay down the cable. So wireless sensors have the attraction there. Okay. But now when you place these wireless sensors, wherever you want to place, then what about power? So they are mostly maybe, for example, battery power. Okay. Changing batteries may or may not be easy. Now if you deploy a lot of wireless sensors, for example, smart dust, across the field, okay, in the water bodies or battlefields, for example, or forest, for example, changing batteries is not an option, okay, for these kind of sensors. So that's where those kind of sensors or those kind of products will have to think about schemes like energy harvesting or energy scavenging, and they will have to employ those strategies. An example of energy harvesting is, if, for example, if you want to put a sensor on a machine, now you can design that sensor which will derive the power out of vibration. Okay, so you don't need a battery or you don't need grid power. You can generate the power using what is available. Okay, or same thing, for example, solar energy. So you drop the sensors on the ground. They can use solar, for example, and you need to design these sensors very optimally. They need to be very efficient, power efficient. So most of the time, these sensors will be sleeping, and they will communicate only when they have something to say, because the RF is still going to use a lot of power, okay, compared to the embedded microcontroller. RF is going to be constant for the power. Okay. Next is packaging and integration. Okay. So we are talking about the sensors and actuators which goes into the different objects, different machines, maybe in the material also. Okay, they may be part of some material also. Okay, so you can embed them in those materials. But there will be challenges. So for example, if we are talking about extreme environmental conditions. Now we took example of aircraft frame. Okay, now the aircraft frame, you want to detect the wear and tear or damage of the aircraft frame. Okay, now it's not going to be easy. Okay, to place the sensors wherever you want to place, because the 30,000 feet, the temperature is very, very low, okay, sub-zero, okay, and so there is a problem. Okay, whether electronics or batteries will work or not. Also, near the engine, the temperature is going to be extremely hot. So how do you package those sensors and actuators where they can withstand that kind of extreme environment and still function? That is going to be a challenge. Okay. So that is what let's go back and tell you one more thing. So another challenge which we can see definitely. Now, we are talking about sensors, okay, and sensors and actuators, right? You know that sensors measure physical phenomena in real life. Now, the accuracy of these measurements depends upon how well it is calibrated. Okay, so if it is well calibrated and it is up to date, then whatever it measures is going to be accurate, or at least you should know the offset. Okay, so I'm off by so many degrees, so you take that into account when you take my measurement. So you need to know that, otherwise you cannot trust. So how are you going to calibrate these sensors which are deployed in large numbers, okay, distributed, okay, maybe in very hostile conditions or inconvenient conditions, etc. So the deployment, calibration, testing of these sensors and actuators is going to be a challenge in many environments. And this problem needs to be addressed to realize the ultimate goal of IoT. There will be some policy changes also. Okay. So for example, these legal liabilities. So what happens now? We are talking about very smart objects which can apply the brakes, stop your car. We're talking about talked about robots which can do a lot of things, and we're talking about industrial applications where the machines they take decisions, okay, vital decisions. So if something goes wrong, then who is to be blamed, okay, and who takes the responsibility? So we need to have the framework, policy framework needs to be designed. Okay, and companies, insurers, and governments need to work together. Also, we talked about security and the privacy issues. So, for example, if the utility installs smart meter into my home, somebody hacks into it and they get all the data about me, or they cause some damage, for example, place some mischief in my home, then who is responsible? Can I hold my utility responsible if for the damage that is caused? Okay. Do we need a strong regulations to mandate security testing, thorough security testing, right from the design stage, okay, where security becomes an important aspect of product development. Okay. It is going to be costly because it has a cost. You want to do that kind of rigorous testing, reviews, etc. Okay. But that may be required. If you want to generate the trust, today a lot of consumers have and end users have a lot of concerns about all these devices getting connected to each other and going on internet. Okay. Do we understand really the problems? Do we understand all implications of all these devices getting connected, okay, to the internet? Because if things go wrong, they can cause a lot of damage, and if the bad people get access to the vital infrastructure, okay, it can cause really a lot of damage. Waste management is going to be a challenge. So all these sensors and actuators, you have deployed, you have thrown it all over, like a smart dust and those things. What about the waste? Okay, when they stop working, what happens to them? Okay. Are they degradable, biodegradable, or we are just creating a lot of waste, okay, spread across? Okay, so that also is going to be a challenge, because once the technologies are available, the companies and the people will make use of it. So you will see a huge number of such sensors and such devices getting deployed, which you don't see today. Just because technology is available and you can derive the benefit, those technologies will be developed. So there is a challenge of waste management also. We may need policies for that also. Okay, so I come to the end of my presentation. So conclusion. So what is the conclusion? So basically, the Internet of Things will turn into a web of things ultimately, okay, where it will impact every aspect of our life. So we'll have these very smart objects or very smart local networks. They will expose their functionality in terms of web services. You will have a huge service-oriented architecture, okay, across the globe. Where today, for example, you know that web application can talk to each other using web services. Same technologies, for example, RESTful web services is one technology which we start seeing in IoT. So it will become a huge web actually, where the things will talk to each other, will expose the functionality as web services. Other objects will access those web services. Okay, so all these things will start seeing in very large number. A reality of ambient intelligence will come true. Okay, so this ambient intelligence, the term is nothing but the things are so smart. Because you can sense anything, you can access anything, you can control anything. Okay, so very smart world. Whether it is your car, your home, your office, your roads, okay, your factories, your offices, so everything, things are so smart. Okay, so everywhere there is a smartness, there is a smart sensing, smart decision making, smart data analytics. Many applications will lead to the ethical debates. is already triggered. For example, in US, there is a lot of resistance to some of these smart meters kind of technologies. Okay. And the reason is that because the privacy issues, because not only privacy issues, but the governments will definitely use the data. Okay. Like in US, the FBI uses your energy data, okay, to monitor, okay, the occupants, for example, when they come, when they go, etc. Also, there are applications where they use where if in particular locality, if the usage of electricity is very high, then they go and check that house because they may be growing marijuana or something in that house. So already some of the government agencies are using these technologies to monitor their citizens, okay? And this will only grow, okay, as well, because now with all these mobile computing devices and all these smart objects and things getting connected to each other and talking to each other, so it will be always where you are, what you are doing. Okay, if somebody wants to know, they can find out about it. So a lot of ethical issues are there and risks are there. Okay. Although security is improving, the total security is near impossible with all these new complexities. So the only thing what we can do is detect the problem early, that there is hack, there is a problem, respond quickly and effectively, and recover. Okay. So recovery is very important. So if the network is brought down, then you should have a capability to bring it up quickly. It has to have a fail-safe kind of mechanism, backup plans, for example, or more robustness. So you don't completely go out of up the network. The last one, I don't want to say, but things are becoming more and more geeky. It looks like the geeks will rule the world. So that concludes my presentation. These are some of the sources which I have given here, and I will definitely urge you to go and see these demos, demo of flying robot, to understand full power of such smart, smart objects, smart coordinating or communicating objects. Okay. Thank you very much. And if you have any questions, I can answer those questions.
Yeah, thank you. The questions are already shared with you.
Questions? Okay, I will check the questions. How do I get it out? Kesha, how can I expand it? Questions pan?
Yeah, if you click on the icon given in the top right corner of the question stand,
Okay.
then it will pop up.
Okay, the first question is any implementation of smart grid and sample example of resource saving and how it is intelligently interact, which protocols, etc. I think we took that example of smart metering and how it can help you save the resources. Basically, it can help you shift the load, and if you shift the load, because at night you don't use resources, you don't energy, so the capacity is going west basically. So if you can shift some of the load to night or off-peak hours, basically you don't have to add new power plants. Okay. And it is expected that billions of dollars can be saved, and a lot of CO2 emission can be avoided if these kind of demand response or variable pricing plans are used. Okay. And there are a lot of protocols. There are ANSI protocols and there are IC protocols. So in America, you have ANSI protocol, which you use for smart grid to connect with utility to get the instructions and also send the data. Rest of the world goes with IC protocol. Okay. Inside the house, you have either power line communication, which uses existing power line, or you use wireless communication, which is Zigbee. Okay. And on top of Zigbee, okay, Zigbee is a mesh technology on 802.15.4 radio. On top of that, you have different protocols like home automation. You have a smart energy profile 2.0. So those are the protocols we choose. And if you have appliances which can understand these protocols, then you can connect them to this network, and you can start controlling these appliances. I hope that answers this question. How viable are the applications to be deployed in India and to witness growth? So I took the example of Bangalore Police, which are already using the video analytics to flag the violations and issue the tickets. Today morning, when I was reading a newspaper, I saw one ad. Okay, and so I'm in Bangalore, so I saw the ad in Bangalore Economic Times, where one of the builder has come up with a smart home concept, and he has put a video, okay, on YouTube or his website, and basically it does the same thing. Basically, you can switch on lights, you can switch on your air conditioner when you leave your house. Okay, you leave your office. So before you reach home, things are working. Okay, your home is cold, etc. And it can detect gas leakage, and it can alert you. Also, you have the video surveillance applications available. If somebody presses the bell of your house, and if you are not at home, then actually on your mobile phone you get a call, and you can see who has visited, and you can also talk to that person. Okay, and there are applications where you can also open the door. Okay, so you can actually control the access control system of the lock, the electronic lock of the door using your mobile phone. And industrial applications it is being used. So you see a lot of RFID is being used, in the retail and manufacturing sector to tag material, to tag the products. Okay, and you can avoid. So one of the advantage of tagging is you can identify the counterfeit products or pirated products, for example. Okay, if you have tags, you can find out such things. So there are applications like that. So these are the few of the applications, and you will see it more and more. Okay, so there is a question on slide 12, which is how efficient is a collision avoidance system. Okay, frankly speaking, I don't know. Okay, how efficient it is and what are the constraints. But the picture, what you see there, image is from the Mercedes-Benz, I think, Mercedes-Benz. And there are higher-end cars which have such systems available, where they can sense. And you have, you might have seen basically the parking assistant and those things. So technologies are getting more and more reliable, where the car can park itself. Okay, and they have the sensors on all sides, so they can avoid the collision. Okay, so technologies are available today to do this kind of things, and I'm sure Mercedes-Benz and BMW's kind of cars, they have the systems, they'll be reliable. Okay, there is the next question is there any standard which governs IoT devices design for interoperable communication? Since different manufacturers can use any of the communication technology mentioned in the slides, which can make them useless if IP-based protocols are not used? Very good question. And answer is, as I said, there are just too many competing standards. I just took one example of smart grid. It is just one use case, okay, of IoT. And there are more than 70 standards. There are standards for short-range wireless communication like Zigbee. There are standards for long-range communication from a building to the utility. Okay, so there is no one standard, okay, which will fit. So there will be multiple standards. Okay, if you have a device which is say IPv6 enabled, okay, then that will be different matter. So then you can access that device immediately, okay, directly. So it is like any other web appliances. So you can access it. So it's like a web server. So products are available today. So we have embedded web servers, embedded Linux in the product, the way it is designed. But otherwise, this IoT is going to be a network of networks. So it is not going to be all devices are connected to internet directly, and you can just access those devices through your browser. It's not going to be like that. Most likely, you are going to access a lot of these networks, local networks, through proxy like a gateway, which will offer security, which will offer reliability, and which will provide you access to the devices which are inside that local network. So the simple answer is there is no one standard which you can use. Even for the same application, there are competing standards, and which we don't know right now which standard will emerge after this. Many of these applications. Would the luggage? So next question is: would the luggage management system at airports be another example? Yes, it can be, because I give examples of manufacturing and retail where RFIDs are used to tag the products or the material, and so that particular product or that material has its own identity. Just because you added the tag, their identity, there is a description of that material, maybe when it was produced, maybe what is its cost and where it is going, right? So so it's like that. Okay, so luggage management system also, if you tag, and then you have the systems which can read those things and then make decisions based on what they read. Then yes, then it can be an example of such M2M kind of an example. Any other questions? Anyone?
Yes, this is the last question I shared with you. We are running out of time. So can you please take this question?
I don't see. This is from Wasim Abbas. He says, "Okay, based on your last point in conclusion, geeks are making this world more geeky. I would like to get your opinion on this. There are more hidden geeks in the world who are not getting proper education. How can we identify and pull them to change the world?" Yes, and I hope that some of these smart technologies can help in the education sector also. Things like mobile, for example, or tablets. Okay? And I hope actually the things become so intuitive that that you can. I mean, it has to be, because the networks has to be flexible, and the products need to be flexible enough and smart enough to be part of network. So you don't have to use a 100-page manual, user manual to get connected. Because you just look at the challenges. Okay, you are talking about devices in large numbers. You are talking about devices which are very small, sensors, etc. You are also talking about mobile devices. Okay? So the devices may not be located in one place, because once you are talking about wireless, they may change their position. Or you are talking about actual mobile devices in your vehicles, they change their position all the time. So you need to have a network which can be formed in ad hoc manner. So the devices can discover. So they have the capability for self-discovery. They have the capability for forming a network without human intervention. And hopefully all these technologies will help everybody to use this technology, which may not be the case today. Any other questions?
Yes, if there are any more questions coming from the attendees, we can take them offline.
Okay.
So now we can conclude the session.
I cannot hear you, Keshav.
Yeah, now with your permission, we can conclude the session.
Yeah, sure, sure. Thank you all, and I hope you enjoy it, and I hope you get interested in this fascinating technologies. The recent NASCOM report has identified this Internet of Things as one of the 10 key trends, technology trends in the world today, like big data, cloud computing, so like that. Internet of Things is one big trend, okay, and there are a lot of opportunities for technical folks to develop these technologies, develop the products, and make use of them for business processes. Okay. Thank you very much.
Thanks, Mr. Girish Deshpande, for this informative session. It was indeed an enlightening session. I would also like to thank our participants for this, for making this webinar a huge success. Uh, the next webinar is happening on the topic how MPLS IP VPN helps reduce costs for service provider customers. We will be having Mr. Raghu Srinivasan, Senior Manager at Rocket Communications, with us today. So see you all Monday at 3 p.m. Thank you.